Hey guys, welcome back everybody. Hope you all are doing great. Guys, today in this video, we will understand real-time scenario-based network configuration according to our requirement. And this is real-time requirement. So first thing is, what is the requirement, right? So first of all, let me tell you about the requirement, guys, how I am going to configure the scenario. And this is the topology for today. You can see, guys, in my topology there are two sides. This is the data center network and this is branch 1 at different location, and both sides, or you can say the data center and branch office, are connected together with the help of two different service provider, right? One is internet and other one is MPLS. MPLS is my primary link and internet is my secondary link, and we need to configure these devices like router 1 and router 2, both edge router. R1 is edge router of data center and R2 is edge router of branch office. We need to configure these two routers so that these two sides should communicate via MPLS, right? But if MPLS is not available, if MPLS is down, then they should communicate via secondary ISP, via backup ISP, which is internet. Fine. This is the first requirement. The second requirement is these user, all the user in data center as well as all the user in branch office in branch 1 should be able to access internet via data center, only. Like this PC, if this PC want to access the internet, they cannot access internet directly like this. They should access internet via the data center. Now if you are thinking that, Praful, why this user should access internet via data center? The reason can be anything. There are multiple factors. Like in data center, maybe we have some policies, and according to the policies, according to the pre-configured policy, I will allow traffic for the internet, right? First I will verify the user, first I will verify the traffic, and then I will decide whether I should allow this traffic to go outside or to go into internet or not. Okay, so reason can be anything, but let's suppose this is my scenario and this is completely real-time scenario. Fine. So guys, the first requirement is configure the scenario in such a way so that these two sides can communicate with each other, right, via both ISP, and MPLS should be the primary ISP and internet should be the secondary ISP, backup ISP. The second is all the users should be able to access internet via data center. Fine. So hope the scenario is clear, the requirement is clear. Now let's begin the configuration. Now guys, I'm going to configure everything from the zero, from the scratch. I have only configured the IP addresses on these devices. IP addresses already configured on all devices, and let me tell you about the IP addresses as well, like how I have configured the IP addresses in this scenario. So you can see on router number 1, on F1/0, my subnet is this one, 1.1.1.0/30. This is my public subnet, right? Public IP address. And I am running .1 on router, on edge router, and .2 is running on ISP. In the same way, between router 2 and ISP, I am running this subnet 2.2.2.0/24. There is one extra 2. Let me correct it. Yes, right. And .1 I am going to use on router, .1 over here, and .2 on ISP side, right? And from both edge routers I am able to ping the internet, right? This IP address, the public IP address of ISP, is reachable from the edge routers, but 8.8.8 is not reachable now because we didn't configure the default route right towards the ISP. And even I am not going to configure default route on router number 2. The reason, router 2 will access internet via router number 1 via data center, right? So we are going to configure default route only on router number 1 towards ISP. Then guys, in the LAN of data center I am running this subnet 192.168.10.0/24, and in the LAN of branch 1 I am running this subnet 192.168.20.0/24. Through MPLS you can see we have L2 VPN. So this service provider have configured their network, and they have given me this subnet 10.1.1.0/24, and I'm going to use .1 over here, 10.1.1.1 on daughter number 1 and .2 on daughter number 2. So you can assume that through MPLS we have direct link between daughter 1 and daughter 2, and both are reachable. My like 10.1 is able to ping 10.2. So first of all we will verify the connectivity. After that, guys, to make communication possible between two private network or public network, like between daughter 1 and daughter 2 via internet, we need what? VPN. So here we are going to configure VPN, right? Otherwise this is my private network, this is my private network, internet is the public network, so two private site cannot communicate over public, right? So we need to create the virtual private network over here. So we'll see the VPN configuration, we'll see the default route configuration, we'll see the routing configuration, and how to configure the failover between MPLS and internet. Done. So don't worry about the MPLS configuration. If you don't know how to configure L2 VPN, guys, you can watch my MPLS playlist. MPLS playlist is already there on my YouTube channel, right, where I have discussed each and every topics in details, right? Like how to configure L2 VPN in service provider network, how to configure L3 VPN in service provider network, and this is the concern of service provider, how they are going to configure the VPN, right? You will have one IP address over here on R1 and one IP address on R2, and both IP address will be reachable with each other. So you can assume that there is one direct link, right? And if both IP addresses are reachable, that means you can configure any routing protocol over here. Like I can configure OSPF here, right? And between daughter 1 and daughter 2 through internet, I am going to create the VPN. This is our task, to create VPN over public network. Okay, so hope scenario is clear. Now let me start the configuration. See guys, I have access of router 1 and router 2 here. Fine. Am I getting any error here? Duplicate IP address 2.2.2.2 on fast Ethernet 0/0 on this interface. So run interface F0/0. What is the IP over here? So IP address on this interface is, as I told you, .1, right? But by mistake I have configured .2 here. Let me correct it. Interface F0/0, say IP address 2.2.2.1 255.255.255.252. Now first of all let me verify the public IP address, like reachability between edge router and internet. So I'm going to ping the remote public IP address from router number 1, the IP address which is running on internet router, which is 1.1.1.2. so ping 1.1.1.2, and you can see I am able to ping. Can I ping 8.8.8? Ping 8.8.8.8. So you can see 8.8.8 is not working. Now let me ping the router 2 through MPLS, right? Because here we have direct link. You can say IP address on router number 1 is 10.1 and IP address on router number 2 through MPLS is .2, 10.2 here, 10.2. Fine. So let me do one thing. Let me verify the connectivity between R1 and R2 through MPLS 10.1.1.2, and you can see ping is working over here, right? And so IP route, even we don't need to check the routing table. Now we need to configure one default route here on R1 so that I can ping 8.8.8. IP route 0.0.0.0.0.0 I can say exit interface F1/0 and next hop IP address 1.1.1.2. Now I am expecting that 8.8.8 should be reachable from here, ping 8.8.8. But yes, you can see, but I cannot ping 8.8.8 from the LAN interface, right? Because right now 8.8.8.8 is reachable through public IP address, right? Through the exit interface IP address. So from the private IP address, how I can access internet? With the help of NAT. With the help of NAT. So first of all, I'm going to configure NAT here so that my data center users can access internet. And guys, you can see in data center I have some resources like this server, right? On this server I can have the application, I can have the portal, I can have the website, right? And those services should be accessible from these PCs, correct? So let me do one thing. Let me here configure the NAT, and I will configure NAT for both the LAN, for this LAN also which is running in branch 1, and for this LAN also which is running in data center, right? Because router 1 is going to forward all traffic towards internet, right? Like branch offices, routers are not going to forward traffic to internet. So let me configure the NAT for both sites. Access list, I need to get one access list number, let's say 10, and I am saying permit 192.168. let's say 0.0 0.0.255.255. So this access control list is matching both the subnet, right? Data center as well as the branch 1. Now IP NAT inside source list, match source from list number 10 from this access control list, and translate private IP address into the public IP address which is running on interface fast Ethernet 1/0, right? And then say overload to enable PAT. Now what will happen? Router 1 will, whenever router 1 will receive traffic for the internet, it will translate source into the IP address which is running on their WAN interface, right? Like 1.1.1.1. So now let me try to ping 8.8.8 from the LAN, guys. Ping 8.8.8.8 and say source, let's say fast Ethernet 0/0, and this time I am expecting the connectivity, but it's not working. The reason is, guys, I have not configured the inside and outside interface. So let me do one thing. Let me say interface F1/0 and say IP NAT outside. This is my outside interface, and interface F0/0 say IP NAT inside. This is my inside interface. Fine. Now again let me check the connectivity. Ping 8.8.8, and now you can see ping is working. That means my LAN users are able to access internet. Now the data center user can access internet, but the branch 1 user can still not access internet. Don't worry, we will see that how to access internet from the branch office as well. Done. So internet is not reachable from data center. Now can these two sites communicate with each other like data center and branch office? No. The reason, do so IP route and 192.168.20.0. you can see we don't have any route available for branch 1, right? And on branch 1 router, guys, so IP route 192.168.10.0. we don't have any route available for data center on branch 1 router, right? So we need to configure the routing. See, on the MPLS link, simply I can enable the routing protocol, or I can even configure the static route. So let me do one thing. Let me configure the routing protocol on MPLS link, and the routing protocol is, most of the time in real time we are using OSPF as IGP protocol. So here also I am going to use OSPF routing protocol. So say router OSPF 1, and then router ID, let's say 1.1.1, and after that, guys, network. So to enable OSPF on the MPLS link, what network command I will run? This network command. The subnet which is running on MPLS link is 10.1.1.0/24. So network 10.1.1.0, wildcard mask 0.0.0.255, and let's say area 0. I am advertising it in area 0. So this command will enable OSPF on MPLS link. Now I am going to enable OSPF on my LAN interface on F1/0. Definitely I will not enable OSPF on the WAN link, right, guys? On this link I will not enable OSPF on this link, right? For via internet, first I will create the VPN, and I will enable OSPF on the virtual interface, right, on the VPN interface. Done. So let me run one more network command here. Network 192.1.168.10.0 0.0.255 and area 0. Fine. Now do so IP OSPF database. You can see we have now router LSA of 1.1.1, and if you will open this database in detail, like you can say router, you can see this router have installed this network in their database and this network, both network, right? The MPLS link and my LAN port, both are in OSPF. Now let me configure OSPF on router number 2, R2, and say router OSPF. Again, process ID I'm going to use 1. You can use different as well because local ID is process ID is locally significant. Here I have configured router ID 2.2.2.2, and again here I am going to enable OSPF on MPLS link by running network command 10.1.1.0 0.0.255 and area 0. Now I am expecting OSPF neighborship between router 1 and router 2 through MPLS, and you can see the log message. Right now we have OSPF neighborship, guys, through MPLS link. Now let me advertise the LAN network in OSPF here, and before advertising the LAN interface, even you can verify the routing table, like do so IP route and 192.168.10.0. so this time this network, this subnet of data center is available in the branch office, right, in the branch 1, right, and the next hop IP address is the IP address of router 1, right, the MPLS IP address on router number 1. Got it? And the exit interface is fast Ethernet 1/0, right? See, the fast Ethernet 1/0 is connected with MPLS. Now let me advertise the LAN network of branch 1 in OSPF by running network 192.168.20.0 and 0.0.255 and area 0, and do so OSPF database, do so IP OSPF database. Yes, now you can see we have two LSA1. This is LSA1 of router 1, this is LSA1 of router 2. So if you will open router LSA of 2.2.2.2, you can see this router have installed this network, their local LAN network in the OSPF database, and this one 192.168.1.1 and 1.2 means 1.0, the MPLS link. Fine. So both are, guys, advertised now in OSPF, so you can verify the routing table of R1. So IP route 192.168.20.0. so this time we have route for branch 1, right, in the routing table, and exit interfaces, you can next hop IP address you can see 10.1.1.2, the MPLS IP address on router number 2. Now the question is, can these two sites communicate with each other through MPLS? And answer is yes. Now these two sites can communicate with each other through MPLS. To verify it, what I can do, I can ping branch 1 user from the data center. So ping 192.168.20.1, which is the IP address in branch 1, and I am going to say source 192.168.10.1, and you can see ping is working. Success rate is 100%. And guys, in the last I will ask you one question as well here, right? We'll not discuss everything, right? I will leave only one concept for you, and I will expect the answer in the comment section. Okay, so now you can see these two sites are able to communicate with each other through MPLS link. How to verify? We can use trace route 192.168.20.1 and source 192.168.10.1 numeric. Yes, traffic is going via MPLS only, right? This is the IP address of MPLS VPN, correct? Now both sides are able to communicate with each other. There is no any issue. But the issue is, what if MPLS bill goes down? See, if I will down the MPLS router, simply I can say shut down to this device. There is no option to shut down the port, shut down the device, turn off the device. Like, or I can do what? I can down this interface. So if this interface will goes down, the connectivity will goes down. Like on router number 1, if I will say interface F2/0, which is connected with MPLS network, and shut down. Now what will happen? OSPF neighborship bill goes down. You can see the log message, right? And now again, so IP route 192.168.20.0, you can see we don't have any route in the routing table. So now these two sites can again not communicate with each other. So that's why we need what? We need a backup, right? We need connectivity from one more ISP for the redundancy. Success rate is 0%, right? Let me do one thing. Let me up the port interface F0/0, say no shut. Again, OSPF neighborship will come up. Now guys, here for the redundancy, I'm going to use what? Internet, right? So internet is my backup connectivity. Backup connectivity between data center and branch office. An internet router is already configured. The public IP addresses are already configured on the routers, right? Now we only need to configure the VPN, right? So create the VPN, guys. Command is, first of all, we need to create one tunnel interface. So say interface tunnel 1, and then I am saying tunnel source. Tunnel source is nothing but the fast Ethernet 1/0, and then say tunnel destination. Tunnel destination means the public IP address, remote public IP address, which is 2.2.2.1, right? The public IP address of router 1. And even you can verify the connectivity between these two public IP addresses. Between the public IP address over here, which is .1, and 2.1 here, 1.1, 2.1. These two public IP addresses should be reachable with each other. Then only guys, we can configure the VPN. And to make reachability between these two IP addresses, what we need route, right? Or there should be default route on both router, like on router number 1 and on router number 2. So I can configure one default route on router number 2 as well towards internet. But if I will configure the default route towards internet on router number 2, what will happen? It will forward all traffic to internet directly, right? So this was a question, like what is the solution here? Should I configure a static route on router number 2? What is the solution? For now, what I am going to do, I am going to configure one static route for 1.1.1.1, because now you can verify the connectivity. Ping 2.2.2.1, and I am saying source 1.1.1.1. See what happened. Do ping, sorry, see ping is not working. So on router number 2, I can configure one static route like IP route 1.1.1.1 to forward traffic to 1.1.1, 255.255.255.255. I'm saying exit interface is F0/0, and next hop is 2.2.2.2. Now again you can verify the connectivity, and this time you can see ping is working, right? That means now I can create the VPN. So again, interface tunnel interface 1 and IP address. On the tunnel interface, I'm going to use any subnet, let's say 172.16.10.1, 255.255.255.0. This is the subnet on tunnel interface between router 1 and router 2. Let me write here 172.16.10.0/24, and .1 is running on router number 1 and .2 is running on router number 2. We have this VPN, right, over the public network. Now on router number 2, interface tunnel 1, and here say tunnel source, again fast Ethernet 0/0, and the tunnel destination 1.1.1.1, and both 1.1.1 and 2.2.1 are reachable with each other. So I have configured the tunnel source, tunnel destination, so that's why you can see my tunnel interface is up. Now IP address 172.16.10.2, 255.255.255.0. Now guys, do so interface tunnel 1. So you can see the tunnel interface is up. Tunnel interface is up, and their line protocol is also up, correct? You can see the configuration like tunnel source, tunnel destination, and the tunnel IP address. Even you can check like this. So run interface tunnel 1. So this is the tunnel configuration, right? Now whatever traffic, whatever data these routers are going to send on the tunnel, it will perform encapsulation, GRE encapsulation, right? It will add one extra header, GRE header, and in the extra header, in the extra IP header, it will add what source? The source of tunnel, right? Tunnel source address. Destination IP will be tunnel destination IP address, correct? And now I am expecting that these two IP address on the tunnel interface can communicate with each other. To verify it, let me take you to router number 1, and from router 1 say do ping 172.16.10.2, and you can see ping is working. Success rate is 100%. Now if my tunnel, my VPN is working fine, then I can configure any routing protocol on the VPN, right? So guys, my routing protocol is already running on both router. The only thing I need to do is I need to advertise VPN interface in OSPF, right? So let me do one thing, router OSPF1, and here I am going to run one more network command, that is, what is the subnet on VPN? 172.16.10.0 0.0.0.255 and area 0. This command will enable OSPF on tunnel 1 interface, correct? On router number 2, router OSPF process 1 and say network 172.16.10.0 0.0.255 and area 0. Now I have advertised tunnel interface in OSPF, so you can see we have now neighborship on the tunnel interface through the VPN, through the virtual private network. Now guys, do so IP OSPF neighbor. Now you can see we have two neighbor, right? One via internet and one via MPLS. One via internet and one via MPLS. On router number 2 also do so IP OSPF neighbor, right? So now we have OSPF neighborship through MPLS and through internet, through both ISP. Now do so IP route 192.168.10.0. For this network, you can see what is the next hop, guys. This network is non via OSPF. Distance is this 110, metric is 2, inter area prefix, and the next hop is 10.1.1.1. So traffic is going via MPLS only. Traffic is going via MPLS only. Now why traffic is going via MPLS only? On router number 1 also do so IP route OSPF. You can see I have this network like branch 1 subnet, and this network is reachable via this IP address via MPLS. Now if MPLS will goes down, interface F2/0 says shutdown, what will happen? OSPF neighborship will goes down through MPLS, right? Now do so IP route OSPF. Now you can see this network 192.168.20.0, the subnet of branch 1 is reachable via, guys, internet, right? Now it's reachable via internet. The reason why best is via, guys, MPLS is, see the metric over here is 1110, and metric through MPLS is only 2, right? So this is the reason why MPLS is best by default, because of cost. If you want to achieve load balancing, simply you can configure the same cost, right? Now I am going to up this interface, MPLS interface, and let me do one thing, let me perform the load balancing. So to perform load balancing between both ISP, what I can do, I can configure the same cost on both interface, right? On interface F2/0, I can configure the same cost, right? IP OSPF cost 1001, right? Or I think 0, because MPLS is also adding, I think, one cost here, right? Now do so IP route OSPF. Now you can see router 1 is performing load balancing here, right? Between both ISP, between internet and MPLS. But I don't want load balancing, so I'm going to remove this command. Even if you want to make internet as a primary ISP, what you can do, you can configure the lower cost on the internet and higher cost on the MPLS link, right? Now again you can see best is via MPLS, right? Now failover is working or not. To verify the failover, what we can do, we can down the MPLS link, says shutdown, and trace route do trace route 192.168.20.1 and source 192.168.10.1 numeric. Traffic is going via, guys, internet. The reason MPLS is down. If MPLS will come up, interface F2/0 and say no shut. When MPLS will come up again, what will happen? OSPF neighborship will come up again, right? When OSPF will come up again, it will receive the branch subnet via MPLS with lower cost, so it will install that route in their routing table. And now if you will again trace route, see the output. Still traffic is going via internet. Just wait for some time. Yes, now you can see the traffic is going via MPLS. Even guys, we can reduce these timers, right? We can modify the OSPF configuration. So now failover is working fine, guys. Everything is working fine. Now the question is how branch office will access internet, because I didn't configure NAT on router number 2. I didn't configure NAT on router number 2. So see, if PC1 in the branch 1 want to access internet, what will happen if this PC will ping to 8.8.8, right? Source IP will be the IP address of PC1, let's say 192.168.20.1, and destination is 8.8.8.8. It will forward traffic to router. Router is going to check what? Their routing table, right? And in their routing table, is there any route available for 8.8.8? Answer is no, right? Even you can verify on router number 2, do so IP route 8.8.8.8. No, there is no route available. Is there any default route? 0.0.0.0? No, there is no any default route available. So router 2 will simply drop the traffic. So guys, on router number 2, I can configure one default route towards MPLS. Or from the router number 1, I can advertise a default route towards MPLS. Fine. And there are many more options as well, right? So tell me at least few more options in the comment section if you have knowledge, right? If you don't have knowledge, then please let me know. I will make one detailed video on the all possibilities. Fine. So on router number 2, what I'm going to do, I'm going to configure one default route towards MPLS, right? Not to the internet directly, because I don't want to allow user to access internet via this link, right? I want these users should access internet via R1 like this. So for now, from router number 2, if you will ping, do ping 8.8.8 and source F1/1. You can see ping is not working. Ping is not working. Even router 2 don't have route. So guys, IP route and 0.0.0, because why I will configure a route for 8.8.8. Like 8.8.8, there are million of server on internet, right? So I'm configuring default route. And next hop will be what? 10.1.1.1, right? The MPLS link IP address. Now what will happen? The user will forward traffic to router. Router will check the routing table. In the routing table, there is no any specific route available, but default route is there, right? So what is the next hop for default route? 10.1.1.1. Do so IP route 0.0.0. You can see the next hop is 10.1.1.1, and 10.1.1.1 is reachable from router number 2. Do ping 10.1.1.1 working, right? So router 2 is going to forward traffic to router number 1. Now question is, can router 2 ping internet? Ping 8.8.8.8. Now ping is still not working. Now what is the issue, guys? Right? You might have thinking that, Praful, this is just because of inside interface, right? I didn't configure the inside interface. So which interface should be inside here? F2/0 of router 1 or the LAN interface of router 2? So guys, on router number 1, this is your question, okay? Please let me know in the comment section. On router number 1, on F2/0, I am saying IPNAT inside. IPNAT inside. Now can I ping to internet? Ping 8.8.8. Ping 8.8.8. See, ping is not working. Now if you think, Praful, you cannot ping to internet from the exit interface, because exit interface IP address is 10.1.1.2, and we have configured NAT for these two subnets for the LAN, right? So source should be 192.168.20.0. So let me set source 192.168.20.1, and now you can see ping is working, right? Means my LAN users are able to access internet, not directly by using the WAN link, right? These users are not accessing internet by using, guys, this WAN link, right? User are accessing internet via router number 1, and even we are getting reply via data center only, right? Now we can apply the policies here in data center. We can monitor the traffic, we can inspect the traffic, right? Whatever requirement we have, according to that we can configure the policy in data center, right? So for all branches we will configure the scenario like this only, right? So these sites are going to communicate directly with each other either via MPLS or via internet, because we have VPN on both ISP. So even you can trace route from router number 2, say do trace route 8.8.8.8 and source 192.168.20.1, say numeric. Now you can see traffic is going to first data center 10.1.1.1, right, router 1. My traffic is going data center first, and after that from data center to internet. And in the same way we will get the reply message. Fine. And for all the branch offices we will configure the scenario like this only. So guys, this was a small configuration of real-time scenario. This is completely real-time scenario. In real time we are configuring the scenario in the same way like this, okay? But instead of router you will have a high configuration devices here. It can be firewall, right, where we can inspect the traffic, we can configure the policies, even we can configure policies on router as well. But on router you have very less options, right? Very less parameters are there, factors are there. But on the firewall you can have the multiple options. Fine. So now guys, you can see both sides are able to communicate with each other as well, like ping 192.168.20.1 and source 192.168.10.1, right? Trace route 192.168.20.1 and source 192.168.10.1. Fine. Via MPLS, both sides are able to communicate with each other via MPLS. Both sides are able to access internet, ping 8.8.8.8 and source, let's say fast ethernet 0/0, my LAN interface. Yes, I'm able to ping. Branch 1 users ping 8.8.8 and source fast ethernet 1/1. You can see ping is working. Both side users are able to access internet, and failover is also working fine. If MPLS will goes down, interface F2/0 says shut down, right? Now again ping 192.168.20.1 from this source. See, ping is still working. Trace route, this time traffic is going via internet. Now can I access internet? Yes. But question is, can I access internet from the branch office now? Because MPLS is down and my branch users were accessing internet via MPLS, right? So guys, ping 8.8.8.8 and source F1/, sorry, not F1/0, yes, F1/1. Sorry, not working. So guys, this is your question. Now tell me the solution. What I can do for this? My branch users are now not able to access internet because my branch users were accessing internet via MPLS, but now MPLS is down. Now guys, again, even this time also I will not allow users to access internet through this link. What I will do, I will configure the scenario in such a way so that first these user, whenever these user want to access internet, first it will reach to data center via VPN. First it will reach to data center via VPN. right? And after that to the internet. So to configure that, what we can do, we can configure a floating default route on router number 2, right? First of all, on router number 1, interface f1 slash interface f2 slash 0 say no set. Now again branch 1 can access internet. Now on router number 2, I can configure one more default route, IP route 0.0.0.0 0.0.0.0 and exit interface is tunnel 1 interface. Tunnel 1, not fast ethernet 0/0. And here guys, I can configure the higher AD value. Even we can apply the track like SLA. We can configure the SLA, this one, like this. Now what will happen? Until and unless MPLS is up, it will install default route in the routing table towards MPLS. Do so run, and we can say include 0.0.0. So see, there are two default route in the routing table. Two default route are in the routing table, but do so IP route include 0.0.0. But in the routing table, there is only one default route towards MPLS 10.1.1.1. But if MPLS will goes down, interface f1/0 says shut down, then what will happen? Now check. Do so IP route. Sorry, first do so run include 0.0.0. Still we have two default route in the routing table. Sorry, in the running configuration. But see the routing table. Do so IP route include 0.0.0. Now guys, the default route is reachable via VPN, right? So this time on router number 1, we need to configure inside on the tunnel interface tunnel 1 and IPNet inside. Now go to router 2 again and say do ping 8.8.8.8 and source fast ethernet 1/1. See, ping is working. And if you are thinking that Praful, ping is working directly through this link, so bro, trace route, do trace route 8.8.8 and source fast ethernet 1/1 numeric. See, traffic is going to data center first 172.16.10.1 through the VPN, and after that data center is forwarding traffic to internet. Done. So guys, this is all about today, right? Today we have understood one real-time network configuration according to our requirement. If you have learned something from this video, guys, please hit on like button. If you have any query, concern, please let me know in the comment section. And if you would want more videos like this, if these types of videos are helpful for you, if you are learning something from these types of video, please let me know in the comment section. Guys, please type yes. Once you will type yes in the comment section, I will get to know these types of videos are helpful for you. It will even motivate me to make more videos like this, more videos on real-time scenario. So guys, your support is required, your appreciation is needed. Once you will type yes in the comment, or once you will say yes, this video was helpful for me, it will motivate me and I will get to know, yeah, you guys are learning from these types of video. Okay, so that's all guys, that's all for today. If you haven't subscribed this channel till now, please subscribe this channel. We'll meet soon in the next video. Till then, stay safe. Bye bye. That's all for today.